This is Module 2, Example 3. It says, suppose someone tells me that the mean GPA for all currently enrolled DCC students is 2.92. I'm not sure I believe what the person told me, so I decide to go out and collect a random sample of 63 currently enrolled DCC students and write down their GPAs. My sample of students has an average, a mean GPA of 2.46. So first ask, what is the research question? So the research question is, what is the mean GPA of all currently enrolled DCC students? Then ask to describe the parameter including the symbol and whether it's known or unknown. The parameter is the average, the mean GPA of all currently enrolled DCC students. Now recall, that would mean we would have to go out and talk to every single DCC student, which is way too many students for us to talk to. We would write down all of their GPAs. We'd have this great big list of numbers, and then we'd have to find the average, the mean of all those numbers. And we can't do that, obviously, but it is a number that exists, and its symbol is mu. Identify the value of the statistic and give the symbol. So we can't talk to every DCC student, so we go out and we talk to a random sample of 63 DCC students, and we then would talk to all 63 of them, write down the 63 GPAs, and find the mean of those 63 numbers, and we find that the mean from our sample is 2.46, which has a symbol X bar. Part D asks, what is the value of the parameter? If the person I spoke to is correct, then alternatively, if the person I spoke to is wrong, then what would we know about the value of the parameter? So one possibility is that the person I spoke to is correct, and the parameter value is actually 2.92. So the mean GPA of all DCC students is 2.92. The other possibility, the alternative, is that that person is wrong, and the mean GPA of all DCC students is some other number that's not 2.92. All right, and in Part E, you're given a chance model that shows the expected statistics that we would get if we assume that the mean GPA of all DCC students is actually 2.92. Notice that this chance model is centered around approximately 2.92, the value we're hypothesizing for the parameter. About half the sample statistics are below 2.92, about half the sample statistics are above 2.92. This chance model shows that if it's the case that the mean GPA is 2.92, then when we go out and collect a sample of 63 students, we should expect to get a sample statistic similar to one of these. So it would be somewhere between maybe 2.81 and, I don't know, about 3 approximately, if you look at these values. So here's 2.8, up here is 3.04, so maybe a little bit above that, 2.81, 2.82, up to about 3.0. Those seem to be the plausible values. Anything above 3.0, anything below 2.81 seems unlikely. So that shows our expectations. The chance model is showing us what we should expect. I then look at what we actually got from our sample statistic. Our sample statistic was X bar equals 2.46. So I look for X bar equals 2.46 on this chance model. 2.46 is down here below the entire chance model. It's off the charts. It's an unlikely, unexpected sort of sample statistic to get if the population parameter was actually 2.92. Because we got an unusual, unexpected sample statistic, we conclude that we have statistically significant evidence against the chance model. In other words, we have statistically significant evidence that the population mean is not 2.92. We have strong evidence that it seems to not be 2.92. If it had been 2.92, then we would have expected to get a sample statistic somewhere between 2.81 and 3.0. That's not what happened, so we have statistically significant evidence against the chance model. So what conclusion do we draw overall? We would say we have strong evidence that the mean GPA of all DCC students is not 2.92. right, then it asks us to just write that out with the proper symbols and notation, the null and alternative hypothesis. So in notation, the null hypothesis is written this way, capital H sub 0 colon mu equals 2.92, read as the null hypothesis is as follows, mu equals 2.92. That's saying the mean GPA of all currently enrolled DCC students is 2.92. Alternatively, our alternative hypothesis in symbols is capital H sub A colon mu not equal to 2.92, meaning the mean GPA of all currently enrolled DCC students is not 2.92. So how does the null hypothesis relate to the chance model? Always is the case that our chance model is built on the assumption that the null hypothesis is true, and so the chance model will always be centered around the value from the null hypothesis. Part J, was the null hypothesis plausible, or do we have statistically significant evidence in support of the alternative? We can say that because our statistic was unexpected, unusual under the chance model, we conclude that we have statistically significant evidence in support of the alternative hypothesis. In other words, in context, we can say we have statistically significant evidence that the mean GPA of all currently enrolled DCC students is not 2.92.